Section 6.3 now will deal with drawing structures. One of the main tasks in organic chemistry is to be able to draw good structures so that you can communicate with other scientists about your molecules. So we need to come up with simpler ways to depict molecular structure. As we saw before, sometimes drawing out all the bonds, all the carbons, all the hydrogens can take some amount of time. So chemists have come up with some simpler ways to draw the molecular structure to still get their point across. What type of molecule we're talking about, what is its structure. And so we can use condensed structural formulas, and that's where carbons and their attached hydrogens are written as a group. So we sort of condense in all the bonds, and we essentially just write out C's and H's and some subscripts along a chain. Even more simply are skeletal line structures. We saw those in the cycloalkanes, and we can also use those in the linear alkanes. They're the use of simple lines and polygons to imply C and H positions. We don't actually write in C's or H's. So skeletal line structures, a quicker way to draw our organic structure. They're simpler, they're more convenient, they're essentially a shorthand. Cyclic alkane drawings are examples of skeletal line structures. Here's cyclopropane. We don't draw any C's or any H's. We imply carbons at the corners, and we then our job is to fill in mentally the number of hydrogens required to bring that carbon up to 4 total bonds. This carbon has 2 bonds, 1, 2, so we mentally add 2 more hydrogens to each corner. Same thing with cyclobutane and cyclopentane. So we can look at skeletal line structures here for the 3 structural isomers of C5H12. We already looked at these when we learned about structural isomers. So the straight chain structural formula, we can condense that into this shorthand where we just write each group without any bonds, and we've condensed all 3 CH2 groups into this small CH2 in parentheses with a 3. But even more simply, we could just write a zigzag chain that has 5 carbons in it. 1, 2, 3, 4, 5. This carbon on the end has 1 bond, so we mentally fill in that it is a CH3 carbon. CH2, 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 CH3. The other structural formula, or another structural isomer, if we move one of these N carbons into the middle, we form a branch point. Now we have 4 carbons across and a carbon on the second carbon, a branch on the second carbon. And that shows in this skeletal line structure 1, 2, 3, 4 carbons in a chain, branch on the second carbon, CH3, CH3, CH2, CH3. And now when we get to this middle carbon here, it already has 3 bonds to it. So we treat that as a CH carbon. And notice it has only a CH here in the condensed formula. We can make another branch off of that second carbon to make this plus-shaped molecule. And that shows up as this X-shaped molecule in the skeletal line structure where we have 4 CH3 carbons and a C in the middle that has no H's on it because it already has 4 bonds to it. So these are the skeletal line structures. They are much quicker to draw. We simply make a few zigzag lines and we have our organic molecule. So some rules. A CC single bond, again as we saw, would be a single line. If we have a double or a triple bond, we'll draw 2 or 3 parallel lines to indicate double or triple. Carbons are omitted, and so are hydrogens, but any other atom, so any heteroatom, an atom that's not C or H, is drawn in. It's chlorine, oxygen, nitrogen, phosphorus must be drawn in. So the CH bonds are omitted as well as the hydrogen atoms. However, if there's a hydrogen atom attached to an O, an N, or a P, for instance, we draw them in. So OH or NH, we specifically show those hydrogens. And then the number of hydrogen atoms that are on a carbon atom is going to equal 4 minus the number of lines to the carbon. So if we see a carbon with only 1 line to it, we understand that it has 3 hydrogen atoms attached to it. So here's an example. This is propane. We have 3 implied carbon atoms, and there are 3 hydrogen atoms on this carbon and this carbon. There are 2 hydrogen atoms on this one. Here is propanol, and that has an OH group off of the first carbon. So again, we have 3 implied carbon atoms. This carbon has 2 H's attached to it because it has 2 bonds already. We draw the O in, that can't be implied, and we have to draw the hydrogen that's attached to the oxygen. We cannot imply an H that's attached to a heteroatom. And of course, there's more than one way to draw then. So if we look at this molecule called 2-methylbutane, it has a 4-carbon chain, a 1-carbon branch off of carbon number 2. It can be illustrated using any of these skeletal line structures. Here's the one that's in the same orientation as the original drawing, but we can rotate this one 180 degrees to come up with this drawing. We could flip this around to come up with this drawing, and we could rotate that drawing to get this one, and rotate some more to get these two. So these are all the same skeletal line structure of 2-methylbutane. So let's look at a few more practice problems. We want to write, in this case we're going to translate the skeletal line structure. We're going to recognize what this skeletal line structure is showing us and write the structural formula and the condensed structural formula. So here again, any point is a carbon atom. There are 5 of them. And we then have to fill in hydrogen atoms on all of these. There are no double bonds, so we just proceed to add as many hydrogens as needed. The 2 N carbons get 3, 3 middle carbons get 2, so that's the expanded structural formula. The condensed formula, simply write out the 5 different carbons with their attached hydrogens. And we can abbreviate that further by abbreviating the CH2 groups. So those all take longer, of course, than just drawing that structure right there. So here is a much more elaborate structure. We start off with 5 carbons in a row. Off of the second carbon is a 1-carbon branch. Third carbon has a 2-carbon branch. Fourth carbon has a 1-carbon branch. Now we fill in hydrogens to bring each carbon up to 4 bonds. It takes a little while. That's the expanded structural formula. The condensed would be CH3, CH, CH3, CH, CH2, CH3, CH, CH3, and CH3. So it's much quicker to draw the condensed, certainly even quicker to draw the skeletal line structure. Clicker question 6.4. Which of these is the best choice for the skeletal line drawing of 3-pentanol? Here's 3-pentanol. Which of these is the best choice for a skeletal line drawing? So remember that each carbon and hydrogen will just get a line, but if we have any heteroatoms with hydrogens attached, we have to draw in those heteroatoms and the hydrogens. So A is not the right choice. It does not show an OH. C shows the O but not the H. D is not the right shape of molecule, and that leaves B. B has 5 carbons in a chain. The third carbon has an OH attached to it, and we've drawn both the O and the H. So B is the best choice in this case.